How to make ECB mode of block cipher secure? The short answer is to change this mode to something else, which we call as Cipher Block Chaining Mode. Now, what is this Cipher Block Chaining? Last time we saw that in the ECB mode, ciphertext of the same plaintext block was exactly same, which means that if some block is repeated in whole of the plaintext, its encryption will be same at all those instances. So now what we do, we chain the ciphertext of the previous block to the current block before the encryption. What does it mean? It means that suppose if we have the encryption of pk-1 as ck-1, pk as ck, and pk plus 1 as ck plus 1, then we will take the ck-1 and XOR it with the plaintext of the current block, that is pk, and then we will do the required encryption. In the next stage, we will take the ck and XOR it with the plaintext pk plus 1. After this, we will encrypt the pk plus 1 to get the desired encryption. Mathematically, it can be represented as ck plus 1 is equal to encryption of pk XOR ck minus 1, which means we are taking the ciphertext of the previous block. But the question arises that what about the first plaintext? We don't have any previous ciphertext for it. The answer is we have a fixed block which we call as initialization vector. Its name comes from the fact that it is used to be at the initial position. So, looking at the same example, we will now attach the IV just at the first of the plaintext. So, this will initiate our cipher block chaining mode, and ultimately we will get rid of the repetition kind of attack. Now we will implement the CBC mode using the ECB mode of the AES. So first of all, we import from crypto.cipher, we import AES, and then we import the get random function, get random bytes. This is to generate the random key and random IV. Now we initialize a cipher. So cipher equal to AES dot new, and we will need a key over here. So now we generate the key for it. So key equal to get random bytes, and we need 16 of the bytes. Now as the cipher is initialized, we need several blocks of plaintext to check it. So first of all, we define the plaintext as an array. So plaintext as an array, and for I in range, let's say 10, we append many blocks. By many I mean 10 blocks. So plaintext dot append get random bytes and 16. So there will be 10 blocks of 16 bytes each as our plaintext. Now we define the ciphertext, and then we encrypt it. So ciphertext dot append and cipher dot encrypt plaintext and the ith element of the plaintext. This is to check if our program is working fine. Later we will just change it for the CBC mode. So we print cipher text is print cipher text. Now we go on run and run without debugging. So it sees that there is some error. Yeah, the error is in defining the cipher. So key, and we need the mode AES mode ECB. So now the mode will be defined. Now we again run it and we see that we have received the ciphertext, and if you notice, it is in terms of array. So this comma is separating the two ciphertext blocks. So like this, there are actually 10 ciphertext blocks. Now we implement the CBC mode. For the CBC mode, we need an IV. So we create an IV over here. IV equal to get random bytes and 16. Now, in the encryption mode, we will start from the first one. So we can choose it like ciphertext dot append, and the first one is that we need to XOR both of the byte blocks, but right now we don't have any method to do that. So I have already created the method to XOR 2 byte datas. So I will just copy this program for an easy implementation. So we go to the CBC mode and we just paste it. So this is just a XOR of 2 blocks of bytes. Now we were here ciphertext.append. Now we XOR, no, the plain text has to be XOR'd first. So we cipher.encrypt, and now we use XOR bytes. So first of all, there will be IV, and then there will be plain text and its 0th value. So this will give the first block in the ciphertext. Now in this next statement, we will change that I is in range 1 to 10, because the 0th case we have already discussed in the previous statement. So now we change this like cipher.encrypt, and we use XOR bytes, and inside it we use ciphertext and I minus 1. So it will take the previous ciphertext and XOR it with the current plain text, and then it will encrypt it. Now we will check if our brackets are correct. So this one is closing this and XOR bytes is closing this, but this append bracket is still left. So we use this one more bracket. Now we check if the program is running fine. And we see that it has given us the encrypted text. Now we see if this implementation has made us secure against the attack that was possible in the case of ECB mode. So now we keep all of the plain text same and check if it is working or not. So we get plain text is equal to this. Now plain text dot append get random bytes 16. So this will be the first byte block of the plain text, and then for I in range 1 to 10 we append it the same block. So we use plain text and its 0th entry. So it will just use the same plain text. For a better representation, we print this. Print the plain text is, and we again print plain text. Now let's see what happens. So it has given us the plain text. If you see, it is just repeated 4xcfxd9, and again here 4xcfxd9 xb4 x1b, and again 4xcf xd9. So these are the 10 blocks which are exactly same. But is the ciphertext same? So we see here that B x83 x129 is there, then B xa8 x8f is there. So it means that each of the block is now encrypted differently. This was the sole purpose of using the CBC mode, Cipher Block Chaining Mode, that we are now secure against the repetition attack. Even if the plain text is repeated, the ciphertext is different in this case.